All right, welcome to day 3. We got page 14 and 15. Let's be putting that in our planners. Also, have your homework out so you're ready to check it when we go over it. And then for warm-up, we want to see, without looking at your study cards, see if you can list the 5 things that a parallelogram implies. So we had 5 tabs on our study cards. See if you can list what those 5 things are. And we're going to pause the video for 3 minutes to give you a chance to do the warm-up, have written in your planners day 3, and to have your homework out so you're ready to check it when we go over that in a moment. So we'll go ahead and pause the video now for 3 minutes. So in no particular order, you should have these 5 things. Parallelogram implies opposite sides congruent. And we get both pairs of those. Parallelogram implies opposite sides parallel. Again, both pairs. Parallelogram implies opposite angles congruent. Both pairs. Parallelogram implies diagonals bisect each other. So then you could do segment bisector implies midpoint. Midpoint implies 2 congruent segments. And then this last one does not show up in proofs really, but we use it in algebraic problems. Consecutive angles are supplementary. And that's just if you went around in a circle 2 angles in a row. So like those 2 would be supplementary, those 2 would be supplementary, those 2, or those 2. So any of those pairs of the same color ones would be considered supplementary. You can stick your warm-up away, going over to homework. After your givens, notice eventually we wanted to get MN congruent to QP, which those were opposite sides in their respective parallelograms. So we need to first take the given parallelograms and do parallelogram implies opposite sides congruent. We can get multiple pairs, but the one we really want is MN congruent to LO in the top one, and LO congruent to QP in the bottom one. So we've got MN congruent to LO, and then LO congruent to QP. Notice LO got marked up in 2 different ways, so that should trigger in our minds that we should do transitive, and we get MN congruent to QP, which is what we wanted to prove. All right, this is pretty much the same proof, but just with angles. So you could do parallelogram implies opposite angles congruent in the big one and in the small one. So in the big one, we get angle 1 congruent to angle 2. In the small one, we get angle 3 congruent to angle 2. Notice angle 2 got marked up 2 different ways. That should remind us that we should be doing transitive. So we get transitive property with angle 1 congruent to angle 3. And the longest proof from the homework. So we got our givens. Automatically we want to do midpoint implies 2 congruent segments, which gives us the ED congruent to AE. So here's ED, here's AE. And we got FC congruent to BF. And we were given AE and FC. So notice AE and FC each had double sets of marks, so we should be able to do some transitive. So for starters, AE had the red marks and the blue marks. So we can say that ED is congruent to FC by transitive. We have that in step 6 there. But then once you get ED congruent to FC, so I'm going to give that the 3 marks now, because now ED is congruent to FC. You can say that ED is congruent to BF as well by transitive property. So if ED is congruent to BF, that gives us one set of sides in those triangles. Then the other ones we can just do parallelogram implies. To get AB and DC, we do parallelogram implies opposite sides congruent. To get angle B and angle G, you can do parallelogram implies opposite angles congruent. And then you've got side, angle, side, because you've got an angle between 2 sides in your triangles. All right, so flipping to the next page and looking at your study cards, down on the bottom we have proving a parallelogram. Well, there's three main ways that we'll prove a parallelogram. We could show that both pairs of opposite sides are congruent, and that will imply a parallelogram. We could do both pairs of opposite sides parallel, that implies a parallelogram. Or the one that is used most frequently is you can do one pair of sides being congruent and parallel to imply a parallelogram. So those are the most common ways. The other ways you could sometimes see diagonals bisect each other implies parallelogram, and both pairs of opposite angles congruent implies parallelogram. The top three are the ones that you'll mainly use in proofs. The other two you might sometimes see in algebraic type problems. So down on the bottom, we want to know if there's enough information to determine if it's a parallelogram and justify. Our justification would be our reasons that we have up above there on the top of page 11. So notice we have one set of sides here. It has congruent markings and parallel markings. Remember, parallel is the arrowhead. And that's that third one in the boxes there. So we could say this one, yes, it is a parallelogram because we have one pair of sides, congruent and parallel implies parallelogram. And notice it's got to be the same pair of sides congruent and parallel. You can't have like the left and right be congruent and the top and bottom be parallel. That would not work out. It's got to be the same pair of sides congruent and parallel. All right, in B, we're working with diagonals. So the only potential one really is the one right below the box. Diagonals bisect each other implies parallelogram. So let's see here. We've got single marks. So that means this must be a midpoint of the top left to bottom right one, and it must be midpoint of the other as well. If it's the midpoint of both, then they bisect each other. So we could say yes for this one, and we could say it's because diagonals bisect each other implies parallelogram. Well, in C, we've got congruent markings, and we're dealing with sides. So we want to think the very top one there. Notice we've got two sets of opposite sides that are congruent. So we can say, yes, this one is a parallelogram, and it is because we have both pairs of opposite sides congruent implies parallelogram. All right, moving on to D, notice we've got one set of parallel sides there, and then the left and right are the same, so they're congruent. So you may think that this is one pair of sides congruent and parallel, but it's not, because they're separate sets of sides. We would need in A, like we had in A, if we were going to use that, it's got to be the same pair of sides, both congruent and parallel. So because it's not the same pair of sides, no, this one is not a parallelogram. In E, we got some angles marked. Well, based on that zigzag, because those angles are congruent, these two would be parallel. Based on this zigzag, those double angle markings, because they're congruent, these would be parallel. Well, now we've got both pairs of opposite sides parallel. Well, that's one of our ways we get a parallelogram, so we'll have yes, and our reason is both pairs of opposite sides parallel implies parallelogram. All right, in F we've got some angles. So our angle one that we have at the very bottom below the box is both pairs of opposite angles congruent imply a parallelogram. Well, we've got one set of opposite angles congruent. Well, we've got to think about how many sides we have here. We got 4 sides. And I want you to think in a 4-sided figure, what should the angles all add up to? Well, hopefully you thought of something like a square or rectangle that has 4 90-degree angles. 4 times 90 is 360. Or you can think of it as this can be split into 2 triangles, and each triangle is 180. So we would need this to add to 360. Well, 60 and 60 gives us 120, plus another 120 is 240. And if we did 360 minus 240, that would give us 120 degrees. So this one is 120 here. So we get another set of opposite angles congruent. So we're in good shape now. So yes, this is a parallelogram, and our reason would be both pairs of opposite angles congruent implies parallelogram. All right, moving over to page 12 and number 2. We're going to use this picture for all 4 of these. And what we need to do is we need to decide what additional information would we need to get this to be a parallelogram. Well, we start out with A, B, and D, C. And I would say make sure to be using a pencil when we're doing this because we're going to erase our markings in between each one. So we've got A, B, and D, C are parallel. So we want to think, well, what else would we need so that it could be a parallelogram? Well, if you already have one set of sides parallel, basically our options are either getting a second side parallel or get that same side to be congruent. So we have 2 options here. We could get AD to be parallel to BC. That's one option. Or we could get the same set of sides to be congruent. So that would be AB being congruent to DC. So let's erase our markings we had put on there. Now for part B, we've got AB congruent to DC. So let's mark that up. Well, we've already got one set of congruent sides. So if we go back over here, if we already know we have one set of congruent sides, we could get the other set of sides congruent, or we could get the same set of sides to be parallel. So we have 2 options here. We could get AD to be congruent to BC, or we could get the same set of sides to be parallel. So you could have AB parallel to DC. We'll go ahead and erase our markings. Next we have angle DCA, which would be right here, and angle BAC, which would be right there. Well, if those angles are congruent, if we make our zigzag, those are congruent alternate interior angles, which would lead to these being parallel. Well, if those 2 are parallel, we're essentially working like we are in part A. So the additional information we would need to have is we would need to have either the other side parallel, so you could do AD parallel to BC, or you could get the same side congruent, AB congruent to DC. Now you could also say your alternate interior angles for the zigzag going the other way could be congruent, and that could eventually help us get parallel, but just listing as the side parallel is a little bit more direct. Let's erase our markings. And for the last one, we got DE congruent to EB. Well, if D is congruent to EB, that means E must be the midpoint, meaning it's getting bisected. But we need the other one to be bisected as well if we want it to be a parallelogram. So the other thing that we would need is we would need to get AE to be congruent to EC, And if that was true, then the diagonals would be bisecting each other, making it a parallelogram. All right, we're going to look at some proofs now, and we're going to actually work backwards. So we're going to start with number 5 on page 13, and then we'll go 4, and then depending on time, we'll maybe do 3 after that. So go ahead, get your statements, reasons, and givens down for number 5 on page 13. So still with a lot of our proofs, we're using our reasons from our original card that we memorized. The one that had our basic 11 reasons, and that's why we memorized them at the start, as they were the foundation for many of the proofs we're going to do. So we'll begin with those in a second, but let's just come up with a plan. Notice we want ACFD to be a parallelogram. So we basically want to get opposite sides in those to be either congruent or parallel. So that's basically what our plan is. And let's keep that in the back of our mind. We got to try and get AD or ACFD sides congruent and parallel. Well, let's just kind of start going with what they gave us. We had D as the midpoint of AB. So that'll give us midpoint implies 2 congruent segments. If D is right in the middle of AB, then that means that AD is congruent to DB. We set it in our proof. Let's mark it in our picture. So looking at our picture and knowing we want to get a parallelogram eventually, it excites me that we have AD marked up. But for that to help us in the parallelogram, we would need AD marked congruent to FC. So although that's kind of exciting that we have AD marked up, can't get too excited because it's not congruent to FC. But maybe we'll be able to get it congruent to FC eventually. So that used our first given. Let's go to the bisects each other. Those are segments, so we should be using segment bisector. Implies midpoint. If they bisect each other, that is the only time that it's going to be the midpoint of both of them. So we can say E is the midpoint of BC and DF. And then if we just talked about midpoint, automatically next we're going to do midpoint implies 2 congruent segments. And we're going to get 2 pairs. If E is right in the middle of BC, that means that BE will be congruent to EC. And if E is right in the middle of DF, that means DE will be congruent to EF. We said some things were congruent in our proof. Let's mark it in our picture. Using different number of markings, we got BE congruent to EC. And then we've got DE congruent to EF. Well, notice we got some triangles there, and they got a bunch of markings on them. That top triangle already has 3 sides marked up, but the right one does not have 3 sides. So we're not ready to prove them congruent yet. But if you notice, we got crisscrossing lines there, so we can easily get some vertical angles. So let's maybe call this 1 and 2. And we can do our vertical angles implies congruent angles. And we're pointing at congruent angles, so we got angle 1 congruent to angle 2. And after you state it in your proof, we can go ahead and mark it up in our picture. Well, now we have enough to get those triangles congruent. We have the angle in between 2 sets of congruent sides, so that'll be side angle side. And for our naming of our triangles, if I called the first one BED, B was matching with C in the other one. So that would match with CEF. So the E's match up because they're vertical. B to E travels along the 2 mark side, so C to E must also travel along the 2 mark side. So BED and CEF. Well, from Unit 8, after we prove triangles congruent, we often use that to get additional sets of sides and angles congruent. Well, let's think about our goal of getting a parallelogram. And think about, are there any sets of additional sides or angles in these triangles that could help us get the parallelogram? Well, if we want a parallelogram, we want congruent sides or parallel sides. Notice that BD was congruent to AD. So if we can say that BD is congruent to FC, BD will get marked up twice, and then we'll be able to do a transitive property, and that can get us a side in the parallelogram. When you have parallel lines, you can often get those from congruent alternate interior angles. So a zigzag that we would want to be looking for is along here. That would be a zigzag that would involve the sides in our parallelogram. So if we can get those angles congruent, that can give us parallel lines. So let's maybe number those 3 and 4. And in step 8, we'll do our congruent triangles. Implies congruent corresponding parts. And there's 2 sets of things we want in there. We want angle 3 congruent to angle 4. But then we also want BD and FC to be congruent. And they're both coming from congruent triangles implies congruent corresponding parts, so you can put them right in that same step. And we'll come back here to mark them up. So we had angle 3 congruent to angle 4. And we just had BD congruent to FC. Well, notice BD got marked up twice. They had the black marks and the purple marks. So we can use transitive property to get AD congruent to FC. So I have AD congruent to FC. And again, that's by the transitive property. And that gives us a set of sides congruent in the parallelogram. Well, we had already got those red angles congruent. They're alternate interior angles congruent, so we can get parallel lines. And we can say that AB is parallel to FC. And we're getting that from the fact that we had congruent alternate interior angles, which implies parallel lines. Now, we said AB parallel to FC. Well, notice AB included our side AD. So that's really saying that AD is parallel to FC. So this is now parallel to that. Well, now we got one pair of opposite sides congruent and parallel. So we're ready to say this is a parallelogram. So our last step, we can say ACFD is a parallelogram. And our reason, we have one pair of sides congruent and parallel implies parallelogram. All right, we're gonna probably just do proof 4, and then we'll call it a day. So let's go ahead and do statements, reasons, and givens. And the parallelogram you can abbreviate with our picture for it. We had one set of things congruent. We got TR congruent to PV. Notice our outer one is a parallelogram, and we want to get our inner one to be a parallelogram. So we've got some triangles there. So we can maybe think about getting those triangles congruent. So let's start with parallelogram implies opposite sides congruent. And we don't know which ones we'll need, so let's just do both pairs. We're working with that big parallelogram. So that would be SP congruent to RQ. And we also have PQ congruent to SR. Maybe we'll put 2 marks there. And I'm going to mark this up with a bracket because it's spanning over several segments. Well, notice in those triangles there, we already have 2 sets of sides marked up. We can get an angle by doing parallelogram implies opposite angles congruent. And the ones that we're looking for in the triangles are angle P congruent to angle R. So we'll mark those angles up. Well, notice in each triangle we have 2 sides and the angle in between. So we'll have side angle side congruent to side angle side. And our triangles, maybe I'll call the first one PVS, congruent to triangle. P to V travels along the 1 mark side, so we'd have to go RTQ for the other one. Keep in mind our goal, we want that inner quadrilateral to be a parallelogram, so we want to try and get sides congruent or parallel in that inner quadrilateral. Because we just got those triangles congruent, we can do any additional pairs of sides and angles congruent that we want in those triangles. And we've got a set of sides in those triangles that can help us for the parallelogram. So let's do congruent triangles. Implies congruent corresponding parts. And we can get SV and TQ to be congruent. So we want to either get SV and TQ to also be parallel, or we want to get ST and VQ to be congruent. Well, notice we've got that big side PQ, and if we chopped off PV, which is also marked up, that could leave us with VQ. And similarly, if we took the big marked up SR and chopped off the marked up TR, that would leave us with ST. So that could lead us to hopefully think to use subtraction postulate. And we want to take one of the big ones, PQ, minus the marked up one we don't want, PV, is congruent to the big marked up one, SR, minus TR. Remember, if you're doing addition or subtraction postulate, the segments you're adding or subtracting should all already be marked up in the picture. If they're not, then you're not able to do it. If we rename this, PQ minus PV is just VQ, and our other one is just ST. Well, notice in that inner quadrilateral, we have both pairs of opposite sides marked congruent now. So we're ready to finish this proof. We can say both pairs of opposite sides congruent implies parallelogram. And we'll have VQTS is a parallelogram. So in addition to doing your homework tonight, I would suggest on your card to be studying the ones that imply parallelograms. So those three on the bottom, we'll want to get those down so that we can be using them in our proofs. That's it for this video. Have a great rest of your day.